The Ukrainian Flamingo FP-5, a homemade missile marvel, a shadow in the sky. The mission begins, not with a whisper, but with a colossal, violent kick. The Flamingo FP-5 is more than a weapon. It is a declaration of long-range capability, a homemade terror engineered to hit where the enemy feels safest. This cruise missile is built around two critical needs: lift and extreme endurance. For the journey, the body's entire central section is dedicated to a massive jet fuel reservoir, the lifeblood of its 1,000-mile flight. Its wings, straight and positioned centrally, are key to aerodynamic lift once airborne. But getting this heavy warhead airborne is the first, most dramatic challenge. It can't just glide. It needs a brutal, instantaneous push to defy gravity. How does a heavy long-range missile escape the Earth's grip? Not with its main engine, which needs time to spool up. It uses a solid fuel booster, a strap-on rocket motor attached to the airframe like a temporary beast of burden. When the mission command is given, this booster ignites, delivering a massive, short burst of thrust, pure, unbridled acceleration designed to get the missile off the launcher and up to speed in mere seconds. This is Phase 1, the launch. Once its job is done, the spent booster is violently detached and falls away. Then, the real journey begins. The main engine, an Ivichenko 25 turbofan Czech trainer jet engine re-engineered for warfare, takes over, scooping air through its dorsal air intake positioned on top to avoid debris, compressing it, mixing it with fuel, and blasting a continuous, powerful stream of fire through the exhaust. The Flamingo is now a small, deadly, unmanned jet. Out in the dark, flying low and fast, the missile is guided by a digital brain that can't be fooled. Welcome to Phase 2, the cruise. The missile is now entrusted to its digital brain and its twin system navigation package. Its primary guide is the GPS receiver, constantly talking to satellites, confirming its exact position on the globe. But what happens when the enemy tries to blind it? What happens if the signal is jammed? Suspenseful silence. That's where the INS inertial navigation system takes command. The INS is a dead reckoning system that feels every shift, every turn, every change in speed. By knowing precisely where it started and meticulously tracking its own motion, it can calculate its position for thousands of miles without any outside help. Together, the GPS and INS maintain a low, fast trajectory, keeping the Flamingo under the enemy's radar, horizon a ghost hunting its mark. Its digital map is spent. Now the missile switches from following coordinates to stalking a signature. The navigation systems deliver the Flamingo to the target area, but they cannot pick out a specific building or tank. For that, the missile needs to see. This is Phase 3, the terminal strike. The missile's transparent nose cone opens, and the imaging infrared IR seeker activates. This seeker doesn't see light. It sees heat. Targets like massive oil tanks, refineries, and processing units are glowing bright white against the cold, dark landscape. A digital box appears in the missile's vision, scanning, locking onto that single, specific, glowing heat signature. The missile is no longer following a map or coordinates. It is autonomously following its target. Its X-form control surfaces work overtime, making microsecond adjustments to keep that glowing target locked perfectly in its center of vision. In the final millisecond of this calculated pursuit, the fuse detects impact and instantly detonates the 1-ton 1,000 kilograms warhead. Why build a new missile when Western ones exist? Because the target is waiting 1,000 miles away. The Flamingo's true power lies in its range. While a missile like the Storm Shadow has a reach of about 155 miles, 250 kilometers, the vital targets, the oil facilities that serve as the financial backbone of the enemy, are often located well over 1,000 miles away. The mission culminates in an explosion, but the timing of that explosion is the final, deadly choice. The end result of this 1,000-mile flight is the detonation of the payload. The warhead itself is a powerful, repurposed component, a 500 pounds, 227 kilograms explosive package. But the true genius lies in its fuse options, which dictate the terminal phase's brutality. It can be fitted with a nose fuse, ensuring an instantaneous, catastrophic explosion on contact. Alternatively, it can utilize the tail fuse FMU Satu Tiga Sembilan, the choice for delayed action. This fuse allows the sheer weight of the missile to act as a bunker buster, penetrating hard surfaces like concrete and earth. Only after burrowing inside the structure does the fuse activate, detonating the explosive after a few programmed seconds. This ability to choose where and when the destruction happens makes the Flamingo not just a long-range threat, but a highly adaptable one, achieving maximum, devastating effect for a surprisingly low reported cost.